Okay, so we're going to talk about 6G spectrum, the path ahead, right? And we are, as Doug discussed yesterday in the introduction, we're getting close to the middle of the cycle of developing 6G. We, next year in 2025, and this is a timeline taken from an Ericsson white paper, there's going to be study items starting within 3GPP that are going to start discussing, the key elements that will go into the first releases of what we're going to call 6G. And clearly, spectrum is going to be front and center in these discussions. There's obviously a lot of discussions that have happened in these 2 days regarding what new spectrum will go into 6G, right? In addition to the current 5G spectrum that is being used. And, there's two main areas of the spectrum that are being discussed today, as what is called, again, in this Ericsson white paper, the essential centimetric range, right? The whole mid-band area that goes, depending on whom you talk to, between 6 gigahertz and 24 gigahertz, 7 to 15, that whole area of upper mid-band. And then there is the sub-terahertz range, somewhere between 90 gigahertz and 300 gigahertz, that might potentially play a role in 6G. It's debated whether that's going to happen from the initial releases or if that will come later on. Now, you probably have not seen this chart. It's a little busy, and it's from,
I like it.
And it's actually not showing the colors right at the bottom. But anyway, it's a plot from a paper that we published recently regarding sharing spectrum and services in the 7 to 24 gigahertz upper mid-band from Northeastern. And it's showing, that in general, however you look at it, 7 to 24 is busy in many ways, right? There's fixed wireless and fixed satellite allocations, radio location services, and there's a lot of also radio astronomy and Earth exploration satellites that are sharing some of these bands, and some of these services have pretty strict interference requirements. Now, if you look at the number of different discussions that have happened within WRC 23, in the FCC white paper on this topic, the NextG Alliance white paper on spectrum, and discussions that are happening within the 3GPP, it looks like subbands including 7.125 to 8.5 gigahertz, 10 to 10 gigahertz are going to be candidates, and other bands in this area. But they are all in different ways. They're going to be sharing spectrum with other services, right? So is spectrum sharing going to be an important native feature of 6G? That's one of the questions that we're going to try to unfold today. At Northeastern, in many ways, we are convinced that Open RAN and in general, the whole ability to observe the radio access network, the distributed disaggregated radio access network, as well as the ability to introduce algorithmic control into the network by means of Open RAN techniques, is going to potentially be an enabler for spectrum sharing, right? So we've talked a lot about Open RAN as, disaggregation, enabling a resilient and secure supply chain, an enabler for AI, but Open RAN can also enable us to share information between different systems, between even different technologies, and use this information at different time scales to make decisions. Similar thing for frequency bands above 100 gigahertz. This is from a different paper that was written at Northeastern with Giuseppe and others. Spectrum sharing through for dynamic coexistence above 100 gigahertz might be necessary. If you want to go above 100 gigahertz, it's because you want very large chunks of spectrum to become available, to be able to transmit at very high data rates. And you can show that the achievable bandwidth, the chunks that are available for transmission, if you are able to share with some of the passive systems that are assigned frequency bands in a static way above 100 gigahertz, if you're able to share with them, you can make much larger chunks of spectrum available, okay? So with all of these premises, I'm going to start introducing our panelists today. We are going to start with Veena Rawat, who is a Senior Spectrum Advisor for GSMA. And then we're going to hear from Mari Silby, Senior Director at US Ignite and National Spectrum Consortium, and lead of the power program of the last 4 years. Amitava Ghosh from Nokia Bell Labs, the head of the radio interface group. And last but not least, Andy Thyssen, the head of XG 5G Admirer. So we're going to start with Veena. Stage is yours.
Thank you very much, Tommaso. I'm really very pleased to be here, and thanks to Alex to invite me here.
Sorry, would you pull Veena's slides, please?
Yeah, so while you're pulling the slides, let me just make one comment. Tommaso's slides made my job much easier. He showed one of the slides for the 3GPP standards, which when I'm going to be talking about what the ITU activities are in terms of 6G spectrum, ITU has a very similar slide, which really gives its timelines for the development of the 6G. But in ITU parlance, we call it IMT 2030, and the timelines are very similar. Basically, the requirements and the 6G vision framework, there was a chart this morning, that's all done, and now they are on the path of defining the requirements, the evaluation of the technologies, and they work hand in gloves with 3GPP in the development of the standards, which is moving on very on a very similar timelines, which Tommaso just showed. Okay, so I, as a senior spectrum advisor to GSMA, I really live and work with spectrum for all services, for all radio services. So I was physically, I only missed one WRC. I chaired one WRC 2003, I was the chair, and I've missed one WRC since WRC 1995. Don't start calculating my age, okay? I have missed one WRC, which was WRC 2007, and it was a landmark WRC in the sense that we started the C-band discussion at that WRC, and we finished, keep your fingers crossed, the C-band discussion, hopefully at WRC 23. And we are now going to bring the 3.8 to 4.0 gigahertz again. So what came out of the WRC 23, obviously, it was a good outcome in many ways. And the big way was that the C-band got harmonized. Now we have 3.3 to 3.8 gigahertz C-band, which is the foundation for 5G, is harmonized. We also had some success at 6 gigahertz, and as you heard yesterday, that CTIA said there were 60% of the subscribers are in that zone where the 6 gigahertz is available for 5G, 5G advanced, or 6G, whatever you want to call it, okay? But it is available for the expansion of 5G. However, it's not available globally. And we know that it's definitely not available in the US, Canada, and many other countries where it has been already decided to go the upper part of 6 gigahertz or the whole 1200 megahertz in 6 gig. The spectrum is 1200 megahertz from 5925 to 7125 megahertz. But the upper part was up for discussion, the 700 meg, and that is already we have it for Wi-Fi unlicensed spectrum. So most of the EMEA region, the region 1, Europe, Russian bloc, Middle East, they all have that. It was one of the most controversial discussions at WRC 23, okay? And many other countries wanted to get access to 6 gigahertz, such as some Asia Pacific countries, but they didn't get in the footnote. But from our region, because I really think more about Americas, Mexico and Brazil got into the footnote to say, in our country, we will use 6 gigahertz for what in the ITU parlance we call it IMT, which is IMT 2030 is 6G. So you will hear me just talking IMT and just think cellular and 6G. Okay, there was a discussion on low band. Actually, I ended up chairing this. It's not easy to get 600 megahertz. Folks have not even done the first digital dividend. So we are talking 600 meg, like we have it in Canada, US, Mexico, and a handful of countries. 600 megahertz, beautiful spectrum from coverage perspective. Was really, really tough discussion, and it's pushed for a good chunk of the world to WRC 2031. However, in the Middle East, we did get the 600 meg. So we have now added more countries to 600 megahertz, where the 600 megahertz is available for 5G if they want to use it. Next slide, please. Okay, so now we are on the road to WRC 27, and WRC 27, one of the difficult items to set the agenda. Forget resolving the agenda, but setting the agenda item for 6G was so difficult. What bands to include, what bands not to include, because everybody had inputs from different regional groups, and they all had their favorite list of bands, favorite in the sense that where they want to protect their incumbents or where they have some reasons. So with all the discussion, we came up with the 3 bands. 4.4 to 4.8, I call it 7-8 gigahertz, and you can look at the numbers, and then 14.8 to 15.35. And I will say in the same breath, we put the 14.8 to 15.35, which is actually global for all the regions we have to consider that band for 6G. However, there was already a talk at WRC 23 itself, particularly the people who have the money on the table, the commercial operators, that, well, 14 gig is very similar to the millimeter wave band. We got 24 gigahertz, for example, from WRC 23. So there isn't heck of a lot of difference. It's good to discuss 14 gigahertz. I'm not going to take it away, but it's kind of an upper mid-band. So the mid-band, the focus is in these 3 bands. But I'm going to focus on 7-8 gigahertz because of the difficulties we had in getting 6 gig around the globe. As I mentioned, we have 6 gig in a decent part of the world, but not in US and Canada and many other countries. So the other point I want to make it, when we did this agenda item, we heard so much about D2D and NTN networks today. Well, there are 3 agenda items dealing with mobile satellite allocations, new spectrum for mobile satellite services. And one of them, agenda item 1.13, that's how we think in terms of the WRC 27 agenda. They're all numbered agenda items. 1.13 is the one which talks about coming up with the regulatory provisions where the satellite operators can use the spectrum for IMT, whether they use the 5G spectrum or before. Right now, the bands they're looking at are the bands really between 694 and 2.7 gig. So we are really looking at the existing bands and not the 5G spectrum. But you can see the writing on the wall, going forward, what happens, we don't know. But the 1.13 is the mobile satellite in the IMT bands in the existing spectrum, 694 to 2.7 gig. The other mobile satellite spectrum is generic mobile satellite. You do any application, or another is just to enable the IoT applications. It is just what we call low data rate in ITU parlance. So that's the item. Next slide, please. Okay. I said I will focus on 7-8 gigahertz. It's close to my heart because of the need for spectrum for 6G. Don't ask me how much. You can look at one of the Ericsson papers recently published. It said 500 to 750 megahertz per operator. And every spectrum amount comes with its own assumptions, so you can look at the details. However, the reason we have an agenda item is because the need for additional spectrum for 6G has been established. 7-8 gigahertz is considered, mid-band, because we are looking at mid-band for 6G. It's complex. It has government users, not only one government users, defense, or you would think, but it has government users. It has fixed you can work with, fixed service you can work with. But we have fixed satellite, we have meteorological satellite weather guys have, we have Earth observations, and we have some transport agencies. So from US perspective, you can see NOAA, FAA, defense, and everybody else is involved. So we can look at, so just to complete the picture for the spectrum, because as you saw in Tommaso's chart, we are looking at mid-band spectrum in WRC 27, but there is an agenda item which is on the preliminary agenda for WRC 31. Every conference finalizes its agenda, but sets an agenda for the next conference down the road. And agenda can change, but the terahertz frequencies, obviously some academia has studied what are the suitable bands for terahertz, and they have now put this agenda item for WRC 31. Next slide, please. Okay, so that's my last slide, I guess. This really shows the timeline for the WRC 27 study cycle. What does that mean? We came out of WRC 23 a weekend after they set the process for how are we going to deal with these agenda items from a technical perspective, because every agenda item has some kind of a sharing and compatibility studies involved. So they set saying which part of the radio communication group of the ITU is going to do the studies. How do you do the studies? You need to know what your newcomer is, what are the characteristics of it, what are the parameters of it, and that's what the discussion we are having right now. For 6G, what are the characteristics and parameters? And most of the time we do the studies, it's not the protection of the newcomer, it's not the protection of the 6G. We're always looking at the protection of the incumbents. So then for the protection of the incumbents, you can imagine with my list of the users, the number of incumbents and the type of characteristics they may have. And given that they're all of them government systems, and some of them, even their characteristics may not be available because they are protected, right? So the work right now is going on, as you can see from the chart. It's over the next 2 years, between now and close to end of 2026, the studies will be done. 6G characteristics will be defined. Whatever the best characteristics of the incumbents we can find, the studies will be done. And then based on their results, the outcome of the results will be published in what we say a CPM, a conference preparatory meeting report. We'll meet and discuss. And that will tell you what the possible options are. What the possible options are for sharing 7-8 gigahertz. And these incumbent services are going to indicate what conditions under which the band could be shared or not shared or may be shared. And that technical input will go to WRC 27. But before it goes to WRC 27, the whole world looks at that technical input, and then they bring their positions to the WRC. So the agenda item 1.7 for 6G and agenda item 1.13 for direct-to-device to use the IMT spectrum, existing spectrum, are two key items, at least from GSMA perspective, which we are spending our time and resources on. Thank you very much.
Thank you, Veena. I'll let you go a little bit over time because of the very nice overview that you were giving, but Mari?
I spoke very fast.
Mari, over to you.
Yes, thanks Tommaso, and actually you're right, that was a nice setup and actually dovetails well into some of the things that I will talk briefly about in terms of how we, not just what spectrum bands might be part of 6G, but how we might reconsider approaches to using those spectrum bands, allocating those spectrum bands, and potentially sharing those spectrum bands, which was touched on here. Just very quickly, for those who don't know me, so I am with US Ignite, which is a technology startup, a technology nonprofit. However, my kind of the relevant background here is that I have been the program director for the Platforms for Advanced Wireless Research program, which is a program of testbeds, advanced wireless testbeds across the country. I'm also now the Chief Program Officer for the National Spectrum Consortium, which is at this point running a number of activities to facilitate discussions between federal and non-federal spectrum stakeholders regarding implementation of the National Spectrum Strategy. So a lot of these discussions, particularly as we are looking at the lower 3 gigahertz in 5G, and as we look ahead to particularly what's going to happen next with the 7 to 8 gigahertz band, potentially in 6G, all of those are on the table for discussion across both the federal and the non-federal stakeholders. So I do want to talk a little bit about, as we think about what some of the new approaches might be that we consider in spectrum sharing and spectrum management in 6G. I think there's 3 things that we need to keep in mind, or 3 things that we need to consider. And the first is, because of the front row seat that I have, I am so intimately and acutely aware of the fact that the policy discussions that are taking place take place at a very, very high and broad level compared to where some of the technology innovation is taking place in the spectrum management space, spectrum management field. Even when we're talking about the technical policy discussions, when you're talking about things like propagation models, or you're talking about things like different types of spectrum sharing scenarios, it is a very coarse perspective. It is very large frequency buffer zones, large time scales. For those who are, intimately familiar with CBRS, you know just how much finer grained we could get. And the reality is that our processes on the policy side at this point are still at a pretty, again, high and broad level. So I think one of the things we specifically need to consider is the fact that the technology can actually move much faster, and we can get a lot more spectral efficiency and do a lot more things in these spectrum bands with some of the technologies that are already being developed and prototyped. So as we think about the policies, we need to make sure that we leave open the flexibility to be able to adjust along the way and not just set blanket parameters for how spectrum is allocated, but maybe think about things like, what are the triggers that would then enable us to move to some more fine-grained spectrum sharing and continue to get more spectrally efficient as we develop those technologies. The auction model and the model that we have worked with for so long, which has a lot of benefits to it, unfortunately, we're not just going to be able to segment off, big chunks of spectrum anymore. And the more we can sort of get away from that, thinking that way from a policy perspective, the more we're going to have a chance to introduce some of these technologies that will make that spectrum usage more efficient. So that's one thing to consider. The second thing, which is a little bit sort of tangential to that, if you will, is we've had a lot of conversation today about yesterday and today about open source and Open RAN and creating this open environment which will enable some of these spectrum sharing approaches. One of the things I want to make a pointed remark about is that when we initially started talking about Open RAN, the whole focus of the discussion was around supply chain diversity and specifically at the radio hardware level. And there are some discussions where that is still the focal point. But the reality is if we end up with Open RAN, if that is our end goal, and really we just end up with 1 or 2 more radio manufacturers that dangle off the end of the radio access network, that's an important thing, but it's not going to stimulate a significant amount of innovation. So as so many people have talked about, ensuring the competitive software market and that there are hooks in the software to enable some of these new competitive innovations, including ones for better spectrum management, is incredibly important. And this audience certainly, I think, is very, very aware of that, and I've heard that sort of very frequently over the last couple of days. But I think it's important to get that conversation out there to a broader audience, because I think it is, again, still too easy to think just about, oh, we're going to plug and play with a different radio. We really need to think about what that software environment looks like too. And then the third thing I would say, and this is going to seem obvious, but we should, as we look at some of these new potential approaches, and as we look at some of the policies as well, these need to be based on actual data-driven decision-making. Again, it sounds so incredibly obvious, but as somebody who's been running a program for wireless testbeds that have collected a tremendous amount of real-world environment RF data, the ability to use that information to inform how you decide to allocate and share spectrum is going to be incredibly important. Models are fantastic. We live on models, and models are incredibly important. But if we don't both validate those models and be able to test and show that some of these things can work out in the real world environment. Nobody's going to take it on faith, and you're going to end up with things like the conundrum around C-band and the FAA, where people published studies that said, yes, this won't interfere, and other people said, no, absolutely, you have no idea that the planes are going to go down. Wouldn't it be great to be able to test and have some of the data to inform those decisions before you made that policy change? And just as another example, we have the FCC ruling on the 5030 to 5091 band to make that available for some command and control technologies for unmanned aerial vehicles. Gosh, that's another one. Wouldn't it be great to test some of them out in a constrained, parameterized environment before we unleash it into the commercial world? So please, 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 models are great. Let's do some of these things in the real world as well. And I'll leave it there for now.
Thanks, Mari. Mitava.
Yes, let us bring out the slides. I'm more comfortable with the slides. So next, please. So I think from our side, I think we call this new band 7 to 8.5 or 7.15, 125 to 8.4 gigahertz, the golden band. The reason we called it golden band, you see, the operators wants to use the same macro grid as the C-band to deploy 6G initially, and that is very promising. So we can use the same macro grid as C-band to deploy at 7 gigahertz, 7.125 to 8.4 gigahertz. There is also spectrum outside the WRC process, the 12.75 to 13.25 gigahertz, but as the previous speaker said, that is more closer to, I will say, millimeter wave band. So the most interesting band is this 7.125 to 8.4 gigahertz. Having said that, what are the propagation characteristics? So in NGA, we see a lot of companies measured this. And we looked at the 38.901 channel models from 3GPP and how it compares to the new measurements. And it is very similar. So the 38.901 model still holds at this new 7.125 to 8.4 gigahertz band, because that channel model is valid from 500 megahertz to up to 100 gigahertz. Okay, so this shows the allocations in various parts of the world. You see, as I'm getting old, I can't see it from here because I forgot to bring my glasses. But anyway, in US, the 7.125 to 8.4 gigahertz is very important. We call it golden band, which is, and the allocation is around, if there are 3 operators, 400 megahertz per operators. But this band, as you have said, is not for exclusive use. There are a lot of incumbents in the band. Next slide, please. So the main incumbents in this band, I will say there are fixed services. And the fixed services, you see, we have to limit the allocation of fixed services to a reduced portion over the frequency range. So we have to move the fixed services, we called it repacking, to the edge of the band. I think there has been decision in moving the lower part of fixed services to the upper part. So, and the other factors are separation distance, and then to combat that, we'll have database-oriented mechanism. The second part of the band is sharing spectrum with space terminal, which Veena said, so which is Earth to space. And what are the procedure for mitigating that? We can have limits on coexistence. We will have limits the emissions above the horizon, so we can do that way. And the final part is sharing spectrum with ground-based and maritime terminals, right? So to mitigate that, we have the Earth station spread over large geographical areas, so we can play with the distance between Earth station and IMT base station to mitigate the interference. And there may be some spectrum sharing mechanism to combat the interference from ground-based and maritime terminals. Next slide, please. So as I said, for fixed services, the solutions is frequency separation, packing, which is AFC type. For the satellite uplink, we talked about coexistence, satellite downlink, we can have an ambit type. Ambit means American Mid-Band Initiative, or we can have a SAS spectrum access system like the CBRS. So that is the trick, right? We have to develop this sharing mechanism for the satellite downlink. But anyway, I think this problem can be solved, but you can see it will be a shared band, not an exclusive use band. And there are three kinds of incumbents in there. So Veena talked about it, and the last slide I will say, why this band, right? So the first is that we have the potential of 400 megahertz spectrum. So compared to, say, 100 megahertz for 5G and C-band, but we can carrier aggregate it, but there is a 4 times spectral advantage in there. And then the path loss and the penetration loss is higher at this band, right? So how to combat those penetration loss and path loss? The solutions are, you can increase the EARP. So in C-band, it is 82 dBm per 100 megahertz. So we have studied it. I think if you move to 85 dBm per 100 megahertz and increase the size of the array from current 64 TX or 192 elements to 1024 elements or 4096 elements, you can combat both the path loss and penetration loss. This slide, although I can't see it from here, this shows the mean downlink, mean uplink, and edge downlink, edge uplink throughput at 2 gigahertz, 3.5 gigahertz, 7 gigahertz, 13 gigahertz, and also at millimeter wave. Now, these are not apples to apples. You can see there are side notes, what kind of bandwidth I used for the 2 gigahertz and 3.5 gigahertz is 100 megahertz bandwidth. For the 7 gigahertz, 13 gigahertz, I used 200 megahertz, and for the millimeter wave, I used an even higher bandwidth. The point of this, with increased number of antenna element and TXRU, we'll have, instead of 64, we'll have 128 or 256 TXRUs. You can have a spectral capacity advantage of probably 3x compared to C-band, right? And the improvement comes from 2x advantage or from the bandwidth going from 100 to 200, for example. And there will be spectral efficiency advantage going from 192 elements to 1024 elements. So it gives you the numerical values based on simulation, and it is all assumptions. But it shows the mid-band is a very high potential of the first 6G services we'll see. And it will use the same macro grid and will combat the path loss, penetration loss using higher downlink EARP, more number of antennas, elements in the downlink as well as in the uplink, going from 8 to 16x. For CPEs, there will be more advantage. So I think this spectrum will support eMBB and fixed wireless access services in the first phase of 6G very well. That's all I have. Thank you.
Thanks, Amitava. Andy?
So I guess I get to back clean up and try to make sure we still have time to have a discussion. Maybe I'll start with, my interest in this came actually from sitting in the audience with maybe 600 other people at Mobile World Congress Los Angeles, back when it was still in a city that I actually liked. And watching Paul Tillman's DARPA Spectrum Collaboration project go down, where we saw all these different teams trying to figure out how they could actually compete with each other, but share spectrum in a way where they were awarded points, right, for the better collaboration that they did, but they were still competing with each other to get jobs done. And that would just, was amazing for me to sit there and watch, right? And I was enraptured, right? There were so many other things, so many other speeches I wanted to go see. I sat there for the entire 4 hours of that competition and watched it from start to finish. Right, it was amazing. And so that really piqued my interest in this. And so for full disclosure, I also chair the Spectrum Working Group in the NextG Alliance. And so, but the good thing is it says MITRE up there instead of NextG Alliance. And so I'm going to share observations that my Spectrum Working Group would not allow me to put on slides if I were to try to drive it through my working group. The first is, to agree with almost everything, I think probably everything Tommaso had on his slides, and so that's easy, right? MITRE also thinks that ORAN, and specifically the non-real-time and the near-real-time RIC, are significant enablers, right, to take a run at spectrum sharing. Spectrum sharing, right, is critical for us, right? When I look at, if you do a crude CAGR from 2G through 5G, about spectrum needs from 1G to the next, typically every G requires at least 85% more spectrum than the prior G. And so here we are in 6G grasping at, what we want to see from a spectrum perspective, and we really still haven't figured out what we're going to do with 5G. I mean, I like to follow the money, right? And in 5G there isn't any. People are deploying a whole bunch of eMBB-based networks so that we can get better Netflix, but arguably, and I do this all the time, and I really have yet to lose the argument, I'll buy a beer for somebody if they can show me an app that I need on my phone that I actually need 5G for, because I don't, right? LTE was good enough. And so then really, what is the killer case for 5G, right? Like Diane said in the last panel, right, 4G opened up the app economy. I think we're really going to see 5G open up as when 5G opens up the device economy. Right, we have an issue where, for the most part, we're just looking at smartphones, iPads, and other things that are 5G-enabled devices. But I'm really excited about reduced capability chipsets. And I realize, we have, 3G, CIoT, we have, narrowband IoT and LTE. So, like, there's been this concept of IoT since we backed into it in 3GPP and 3G. But really, once we start to enable, like, the differentiator is when I can enable 60,000 devices on a single G node B, that's interesting to me. Right, that gets after the MMTC side, the massive machine type comm side of what 5G was supposed to deliver. Right, then there's the ultra reliable low latency piece. Right, so I think reduced capability chipsets, when those start to hit the market, when we can actually go do things like my company tried to do years ago, which is to buy a 5G enabled drone, couldn't do it. Right, and then use 5G to do beyond line of sight flying with the drones, couldn't be done at the time. Now we can do it. Right, so that we started to see some stimulation of the device ecosystem, but it's still not quite there yet. So why does this matter when it comes to spectrum? Well, I mean, it was said in the last panel too, what are the use cases? What's the use case for 6G? What's the compelling thing that I need 6G for that I can't do with 5G? And I just argued, what's the thing I need 5G for that I couldn't do with 4G? And I think that, to me, it's following the money. Right, and when you look inside my working group, you see that the money, the business politics play itself out. For the most part, our operators are not interested in spectrum sharing. They're in love with cleared license spectrum because of the predictability of it. Right, their incumbent manufacturers do a really good job nodding up and down whenever those operators who write the checks say, yeah, that's the kind of spectrum that we want. Right, we have shared license spectrum. Right, CBRS is the best example of that. I think CBRS, so I'm not saying anything bad about CBRS. I think it's great that we did it. It took 10 years from start to finish to get there. That's 6 releases inside of 3GPP, and I think it's time to do better. And so I think we're in a position now with some of the technology advances that we're seeing, where we can actually do better when it comes to shared license spectrum. And then there's the unlicensed space, right? The United States has more unlicensed spectrum than any other country in the world. I think we can do better there too. And so then managing the politics inside the Spectrum Working Group, the only way I can get there's one camp that hates at least one or two of the other camps. Right, they're like, no, we can't do that. That's antithetical to our business model. And so they object to everything. And so the only way we can drive this forward is to say, okay, well, we have unlicensed, shared license, cleared license. We need to move them all forward at the same time. Right, and we need to do a better job of figuring out how we actually use all 3 types of spectrum access at the same time, better than we've done in the past. So that at least allows us to, put our propeller hats on and have good nerd conversations around how we can do better spectrum access, but still, where's the money? Right, and I think it's the money that drives all these decisions, right? Whether it's lobbying with our regulators, lobbying with Congress, right? Figuring out how to monetize the investments, the billions of dollars of investments made in 5G. And we have an applications working group inside the NextG Alliance, and I think Gadong's group has done great work in trying to figure out what we're going to do with 6G. The most compelling application that I found so far that I actually don't think is solvable with 5G is mobile augmented reality. There's a bunch of miracles that have to occur in order to really enable that, not the least of which is that 15% of people get nauseous just by putting the goggles on in the first place. But being able to do that, right, this expectation of mobility, if you look at not densifying the network beyond what we've already done, so we're looking right in that mid-band or lower kind of range, because otherwise the operators can't afford to build the networks to support these use cases. There's not enough spectrum that can be cleared and licensed where I think the cost of relocating the federal incumbent radio system would be more than the value of the spectrum at auction. So spectrum sharing is where it is, right? If we don't figure out spectrum sharing in a way that evolves it well beyond where we're at with CBRS and spend as much time figuring that out as 3GPP has done and cleared licensed, then we're probably from a North American perspective not going to be leading, right, the race to figure out what we're going to end up actually doing with 6G, let alone the technology enablers. And just to say it, right, and I apologize, I've gone way over my from an O-RAN perspective, big fans of O-RAN, like I said, with the E2 and the A1, right, when we're talking about trying to figure out how to do this, standardizing these things, right, again, it breaks business models. If we can figure out how to do things like PRB blanking, beam muting, beam steering, and all the other layer 1, layer 2 tools, right, that go into controlling 5G new radio, if we can figure out how to do that through XApps and RApps, we go boom to the proprietary schedulers sitting inside our incumbent manufacturers right now, and we open up an entire new ecosystem where the John Deeres of the world can be the ones coming in as a value-added reseller, integrating on top of 5G, selling into new verticals, because they're the ones who know how to do precision agriculture, right, not our incumbent manufacturers. So there's, you follow the money, right, you follow the spectrum, and I think there's a whole lot of innovation to be done. I'm just not sure that we're ready, right, to chase some of these different models.
Wonderful, thanks. I think there's lots of very interesting points here. Time for questions from the audience. Do we have questions? Oh, come on. Well, Irfan.
Thank you. So you spoke about the 6G spectrum, but I believe that there was the millimeter wave spectrum of 5G that was in the 26 or 28 gigahertz band. Is that also under consideration for 6G, or is that out of race?
So I can talk about area C. So in 5G, we introduced this new radio at this millimeter wave band, 28 gigahertz, 39 gigahertz. So there were some fixed wireless access services in this band, and say stadium deployment, and so indoor deployment mainly, because you have 800 to 1600 megahertz of spectrum. But the issue with millimeter wave was a couple of things. One is the penetration loss, and so you can't cover inside from outside or vice versa, right? The other problem with millimeter wave was blockages, right? So these are the two issues with millimeter wave. And to deploy millimeter wave in a mobile network is very difficult, right? You have to densify the network, and the densification has a lot of logistical issues. You have to acquire new sites, right? You have to put power in there, and so on and so forth. So that's why millimeter wave, but I still believe that in the era of 6G, there will be some development in millimeter wave which will advance the cause, you see. But I think the main focus in 6G now is this mid-band, but millimeter wave will be also addressed in making it more perfect.
I'll have one last question to conclude the panel.
May I add something to that?
What was that? There was a question there? Okay.
Bob Stevens from Keysight. Just a quick question on, so what do you think the role would be to have using the network as a measurement device? So in other words, having features where you have the network be a measurement instrument for spectrum management, and also things like comp, coordinated multi-point, things of that sort. Is there a way to connect the dots between those things? To have runtime analytics, I guess, to manage some of the spectrum sharing instead of what we have now.
Yeah, well, I mean, there's a bunch of potential features, right? I mean, that we earlier panel talked about integrated sensing and communications. I think that's a massive enabler for what we're talking about, right? So the combination of the stuff that 3GPP does with a combination of the stuff that the ORAN Alliance brings to the table, I think, right, would work really well. That combined with, edge compute, right, to then sort through all the data that you're generating, right, throughout the data, right, using the G-Node Bs as basically radar systems to characterize the RF network.